The next project will be held in English. It's the project SoRec, and I welcome the scientist for emerging technologies for a circular economy, Shohreh Kia.
Yeah.
Applause.
So hi, I'm going to surprise you. I'm talking English. I'm sorry that.
Please take the micro.
Okay. Can you hear me now? Yes. So I'm sorry. I would love to talk in Deutsch, but I'm not sure if I can talk in Deutsch and you can understand what I'm saying. So it's better I make it in English. So I'll a little bit explain about what is the intention and what is the aim, why we wanted to do this. So the intention for this project is we try to make the work for mining people and for recycling people much easier and much safer regarding to the health. So first we started with the first machine, which is an eddy current machine. This machine which you see in the picture, the left side is the belt and the right side is the machine. So this machine, the job of this machine is an analog machine. It's not completely digital. It's separate the non-conductive metals like brass or aluminum or zinc or copper from non-conductive, like other kind of waste stuff like plastic, glass, or rubber or some other things. So the machine works with some magnetic drum that the drum starts rotating and it has a magnetic property. So when the material from the belt, they start moving to be processed from the machine, at the center of the belt, when they reach the separation, that's the part that separation will happen. So the drum is rotating under the belt, and at the center, the separation will happen. So completely, this machine is analog, and it's 24 hours is working, and people, they have to stay there for 24 hours for 3 shifts to check if the machine is working well, if the drum is still working correctly, if the rotation, if the speed, if the vibration is enough, if the belt is not in fire, or if the material they are in the container. So since the machine, it's in the factory, which is really dusty and noisy and not really in a good atmosphere regarding to the health. So we decided to make it completely digitized, that no one needs to be there and they can sit in the house and just check it, remotely. So this is the material we are working on that. We are testing the AI model with this material. We started with the 4 millimeter till the size of 1 millimeter, which is really challenging for the 1 millimeter. So what these materials they are mix of, as I said, plastic, glass, wood, or copper, aluminum. The aim is to get as much as accuracy we can get from aluminum because we can recycle them. So this is inside the machine. I tried to make one good image for you guys that you can see inside the machine, which you see that first is the belt, first is a container which material are coming down, then is the belt, then is the magnetic drum under the belt at the middle of the belt, and then is the eddy current motor which run the engine, which run the drum to work. So the plan is to make each part of this machine digitized. So it can be with sensor, it can be with camera. So where we can use camera to get the information, to get the data, like from material, for example, what shape they are, what age they are, what color they are, or what, I don't know, what size they are. So as much as information we can get from material via drum, via belt, via vibration feed, we can get this information, and we have a partner company that they make PLC. So the plan is to completely change the control unit of this machine, which is manual now, to the PLC that it can be digitized. So this is the PLC part that they are going to make new sensors and new devices that they can change it, that they can remotely, they can change it, they can check it. So in case, for example, if in the belt, we see, for example, some material is there, some clamping of material is there, and we don't know what is that, and nobody is in the factory at that time. So remotely they can check, okay, camera is seeing that something is there, and now machine itself will decide to turn off the drum or to turn off the machine or to slow down the belt, or even they can send a message or they can call to some employees that, you know what, there is some problem on the belt. Now somebody needs to come. So it's to reduce the working hours for worker and improve the health of the employees. This is also what our partner company they are going to do. They are going to make the new sensors, as I said, from, I guess, steamers, and they will change the control unit. And I'm working for Professor Benjamin Leiding from TU Clausthal, and Dirk and Eric, they are the partner company that we are working with them, and they are responsible for PLC part. Yeah, thank you.
Thank you, Ms. Kia.